Alright, welcome. In this video, we're going to do some factoring practice, and we're going to be practicing when we're factoring a quadratic and the leading coefficient is not 1. And so you're probably working on this, and it's a worksheet, one of those pizzazz puzzles where you fill in the letters and stuff. I'm just going to work the factoring part of it, but let's get to it. Right, number 1, 3x squared plus 7x plus 2. So I need to think about two numbers. I'm going to multiply 3 and 2, and I get 6. So I need two numbers that multiply to 6 and add to 7. Okay, so that's going to be 6 and 1. Okay, so I'm going to split up the 7x into 6x and 1x. I'm realizing I didn't leave enough room for that. Okay, so the first number is going to be 6, second number is going to be 1. It could be 1 and 6 if you like, doesn't matter. So 3x squared plus 6x plus 1x plus 2. And now I'm going to group and factor. So I'm going to think what's common to the first two. That's going to be a 3 and an x. I multiply by x plus 2. And there's nothing really in common to x plus 2, so I got to factor out a 1. And then I'll factor the x plus 2, because that's common to both of the things that I'm adding together right there. So I'll factor out the x plus 2. I'll be left with a 3x plus 1. Alright, number 2 is 2x squared plus 5x plus 3. And I think that this was a polynomial that you had to factor in the homework, so I just recorded that. It feels familiar, but we're going to do it all the same, because maybe you didn't just recently do the homework. So for number 2, I'm going to look for two numbers that are multiplying to 2 times 3 is 6, and adding to 5. Yeah, and it's going to be 2 and 3. Or 3 and 2, whichever one you think will make your factoring easiest to look at. So 2x squared, yeah, I might say plus 2x, right, because that looks easy to factor. Plus 3x plus 3. Then what's common to 2x squared and 2x? The 2 and 1 power of x. And then you're left with an x plus 1 and 3x plus 3. Those both have a 3, so I'm going to factor that and be left with an x plus 1. I'm seeing the same thing, so I know this is working out for me, and I get x plus 1 multiplied by 2x plus 3. Number 3 is 3x squared minus 16x plus 5. So I'm looking for two numbers that multiply together to equal 3 times 5 is 15, and that would add together to equal negative 16. So I'm thinking negative 15 and negative 1. So I'm going to split up that negative 16x into negative 15x and negative 1x. But I don't think I need to write in the 1. And then I'll be adding a 5. Okay, so I factor on 3x squared and negative 15x. That would be 3x multiplied by x minus 5. And then I need to get x minus 5 out of these next two things, so I'm going to need to factor out that negative. So factor out a negative 1 multiplied by x minus 5. Yeah. And then I'll factor the x minus 5, and I'll be left with a 3x and a minus 1. Very good. There you go. 4, I'm going to be searching for two numbers that multiply to 14 and add to negative 9. Okay, 7 times 2 is going to be the only factors of 14, so I know this is going to need to be negative 7 and negative 2. Okay, so I'll split up that negative 9x into negative 7x and a negative 2x. When I group and factor the first two, I can pull out a 7x and be left with an x minus 1. And this one's got a 2 to each of them, but I need to take out the negative, so I'm left with an x minus 1. So minus 2 times x minus 1. I think, does this make sense? Does this work? Yes, okay. And then I've got x minus 1 multiplied by 7x minus 2. Number 5, I'm looking for two numbers that multiply to 6 times 1 and add to 5. So that'll be 3 and 2. I've got One is 3, the other one's 2, and it doesn't matter how you split up the 5u. I think it's going to be pretty similar either way. So 6u squared plus, maybe I'll do 2u, just to show you that it really doesn't matter, plus 3u plus 1. I'm going to say what's common to 6u squared and 2u, just the 2u. And I'll be left with 3u plus 1. And then, well, I already have 3u plus 1 over there, so I'll just factor out a 1. That won't change anything. And then I will factor the 3u plus 1 and be left with a 2u plus 1. Alright, number 6. I'm looking for two numbers that multiply together to equal 8 times 1 is 8, and add up to equal -9, so it's going to be -8 and -1. So 8u squared minus 8u, you could have done -1u minus 8u, but I'm going to do it this way, plus 1. And then I'll factor out an u from the first two. I'll be left with a u minus 1, and then I'll need to factor out a -1 to get that same u minus 1 over here. I'll factor out that u minus 1 and be left with 8u minus 1. Okay, number 7. I'm looking for two numbers that multiply together to equal 10 times 3 is 30, and add to equal 17. That's going to be 15 and 2, yeah. Okay, so I take that 17u squared, or 17u, and I turn it into 15u and 2u. Plus 2u plus 3. Right, and I think what's common to 10 and 15? I think just that 5, and also a u. So I'll be left with a 2u and positive 3. Then I already have 2u plus 3, so I'll just factor out a 1, and then factor out 2u plus 3, and I will have it factored down all the way. All right, cool, great. Number 8, that's 9u squared minus 9u plus 2. We need two numbers that are multiplying to 9 times 2 is 18, while adding to -9. Okay, I'm thinking -6 times -3 is positive 18, yeah, and they would add to 9, so -6 and -3. Alright, so I'll take that -9u and I'll split it up into -6u and -3u. So 9u squared minus 3u minus 6u plus 2. And then I take the first two, 9u squared and -3u, and I can factor out a 3 and 1 power of u. With -6u plus 2, I can factor out a 2, but I should probably factor out the -2, so I'm left with positive 3u. And then hopefully I'll have a -1. Yeah. And then I can factor out 3u minus 1 and be left with 3u minus 2. Number 9 is, let me see, I kind of went too aggressively on that. It's 5u squared plus 11u plus 6. So I'm looking for two numbers that are multiplying to 5 times 6 is 30, and adding to 11. Oh, I was only thinking of factors that weren't 5 and 6. Okay, this is going to be 5 and 6. This one. You know, it's the thing, and I can put the 6u or the 5u there. I feel like I might just put the 5u there because it has more to factor with the first thing. That's kind of what I'm considering when I do this. 5u plus 6u plus 6. Right, and what's common to 5u squared and 5u? Well, just 5 and 1 power of u. You'd be left with a u plus 1. And then with 6u plus 6, I can factor out a 6 and be left with a u plus 1. Then I factor out that u plus 1, and I'm left with 5u plus 6. And that's as far as I can go. Alright, now the second half of these, I'm going to, maybe I'll go a little faster. With number 10, I'm thinking of two numbers that multiply to negative 3 and add to positive 2. So it's got to be positive 3 and negative 1. Yeah. So that's 3n squared plus 3n minus 1. I can factor out a 3n and be left with an n plus 1, and a negative 1 and be left with an n plus 1. And then I'd have n plus 1 multiplied by 3n minus 1. Oh, whoops. Okay. With 11, I'm looking for two numbers that multiply to 5 times negative 1 and add to negative 4. And I'm going to say that will be, I'm thinking it's going to be 5 and 1 somehow. Negative 5 plus 1. Alright, so 5n squared minus 5n plus 1n minus 1. I'll group and factor. Can only factor a 1 out of that, but that works because I can get the n plus 1 out and be left with 5n plus 1. Okay, number 12. Yeah, I'll hit that in my shot. Okay, 7. So mn equals 7 times negative 2. We multiply a and c and we get negative 14. M plus n is negative 13. So I'm thinking negative 14, positive 1. And I'll get 7n squared minus 14n plus 1n minus 2. I'll factor out the 7n, n minus 2, factor out a 1. These all keep being pretty similar. But that's good. You know, if you're working this because you need the extra practice on the factoring where the leading coefficient is 1, this is exactly what you need. You need that repetition. You need to do it right a bunch of times so that it's just second nature. Okay, you factor out the n minus 2, and you are left with a 7n plus 1. Let me clear out the screen here. Alright, next we'll do number 13, where we're looking for two numbers that multiply to negative 14. Oh, we did one very similar to this, but m plus n is negative 13. So I think, again, negative 14, positive 1. Yeah, negative 14, positive 1. So I'm going to say 7n squared minus 14n plus 1n minus 2. And I'll factor out a 7n from the first two, and a 1 from the second two. Then factor out an n minus 2, and I'll be left with 7n plus 1, and I will have factored it. Alright, now 14 is going to be, on there, 3 times negative 5 is negative 15. Looking for numbers that add to negative 15 while adding to positive 14, and that will be positive 15 and negative 1. Oops, I don't need that. And so that's something a little different. So I'll split up that middle term, 3t squared plus 15t minus 1t minus 5. Then factor from the first two terms, a 3t, be left with a t plus 5. And then if I want to get a t plus 5 out of negative t minus 5, I'm going to need to factor out that negative 1. And then I'll factor out that t plus 5, be left with a 3t minus 1, and I will have the thing fully factored. Alright, number 15. 4 times positive 7 is 28. Again, because 7's a prime number, it's really going to limit your options for, so at this point, like if it's 7 times 4, it's 7 times 2 times 2. Your options are 7 times 4 and 14 times 2. That's it. And I guess 28 times 1. But of those things, the only thing that can combine to make 11 would be 7 and 4. So m plus n equals negative 11, so I'm going to need negative 7 and negative 4. So 4t squared minus 4t would go real well with a 4t squared, minus 7t plus 7. Factor out a 4t and be left with a t minus 1. Over here I should factor out a negative 7 to also be left with a t minus 1. Factor the t minus 1, be left with a 4t minus 7. And there it's fully factored. Let's see, I bet I can see it. I think I've got stuff below this too, other factoring practice worksheets, but that should leave me enough room to finish this out. So, number 16, two numbers that multiply to 6 times negative 1 while adding to positive 5. Positive 6, negative 1. Alright, so 6t squared plus 6t minus 1t minus 1. Okay, factor out a 6t from the first two and a negative 1 from the second. Factor out that t plus 1, be left with a 6t minus 1, and there it is, fully factored. And our last one, number 17. 3 times negative 7. We're looking for two numbers that multiply to negative 21 while adding to negative 20. So I'm thinking negative 21 and positive 1. So this 3t squared, maybe I'll do 3t squared plus t minus 21t minus 7. I think I'm going to need just a little bit more room. Factor out, I guess, just the t from the 3t squared plus t, so I'd be left with a 3t plus 1, and I suppose I'd factor out a negative 7 there, because they're both negative, and 7 divides 21, so I'll factor out the negative 7, and now I'll be left with a 3t and a plus 1. So when I go to factor the whole thing, I've got 3t plus 1 multiplied by t minus 7. Alright, that's all of the factoring practice for this particular worksheet. If you still don't think you've done enough, I do have one other worksheet of the same thing, factoring where the leading coefficient's not 1, so you could practice even more. But I think if you just did this 17 times with me, if you tried it on your own and you did it right 17 times, that you know what you're doing and you're probably ready to move on to a different type of factoring. So thanks for watching.